back. Today's question is single number 3. The question is that we are given an integer array where every element appears twice, but only two elements appear only once. We need to return those two elements in our new array in any order. And we are required to write an algorithm that runs in linear time and uses constant extra space. Approaching this question, you would notice that we can use XOR here because XOR of two same elements will give us 0 as answer. But eventually, you would notice that XORing, applying literally XOR to our all the elements in our array would give us XOR of two elements that are non repeating that are different. Now we could think that we could literally store it in a hash map and then move on further for our solution, but we are required to use constant extra space, so we cannot use a external memory here or external data structure here because it violates our requirements. Now moving towards the most optimal solution, the intuition that help us in solving this question is when we XOR all our elements, the two elements that are present only once, there must be there must exist a bit that is not same in those two elements, right? Because if all the bits of any two numbers are same, which means they are equal, but it is not. We are literally given in a question that two elements, exactly two element, we are only ones which are different from each other. So those two elements would have at least one bit. There must exist a one bit that is different in those two bits. There could be more bits that are different from two numbers, but we are interested in that one particular bit, and we will be choosing that the leftmost bit, sorry, rightmost bit from the right, uh, least significant bit that is different in those two numbers. Uh, we are interested in that particular bit. Now, what we could do is we could maintain two buckets. One bucket would consist of that one particular bit that is on, and other bucket would consist that one particular bit is off, right? Now you will notice that consider this example where 1 2 1 3 2 and 5 are given. Let's consider this 3 and 5. So 3 and 5 differs in the last third bit, right? Because in 5 the last third bit is on, while in 3 that last third bit is off. Now you will notice that in all the elements, as all the other elements are same, the last third bit will be either off in all the other that are consisting in this bucket or on the other bucket. If one is placed in off wala bucket, you will notice that the other one will also be placed in that other or bucket. And then after, if we XOR those all the both buckets individually, we will be simply getting the remaining answer of two elements in first wala bucket and in second bucket. It's because that XORing two numbers is zero that are same, and we will use this property of XOR in determining our remaining single number. Now let's continue. First of all, we will be XORing all the numbers present. This would give us XOR of two single numbers. Now XOR of two numbers, which means that in what bit they are different. Now we will uh, get that particular bit which is different in our two single numbers. How will you do that? You would have come across in previous questions that XORing n and n minus 1, sorry, n and n minus 1 would clear the rightmost bit that is on. And now if we XOR it with our original XOR number, we would simply be getting that particular bit which is different in both the single numbers. So here I am storing first of all XOR of all the numbers in XOR variable, and now XOR and XOR minus 1 will clear the rightmost bit, and XORing it with the original XOR would return here in this bit all the numbers are 0 except that one particular bit that is different in both the two numbers, right? So here we are getting that particular bit rightmost, that particular bit that is different in both the numbers. And we will iterate our nums array one more times to check that if this bit is set or not in for all the numbers. We will check if this bit and our nums array is not equal to 0, which means these nums of array consist of that particular bit set, and we will move that particular bit in our bucket 1, and we are consecutively XORing that particular bit, so that at last when all the numbers are iterated, we will be remaining that one single numbers in both the bucket. If that bit is if that bit ending with that nums of I and bit is greater than 0, which means that our number has that particular bit on, and we will be moving in our bucket 1. Or else if that particular bit is off, we will be XORing it to the second bucket. And at last, after all the iterations are finished, our bucket 1 will consist of one single number and bucket 2 will consist of other single numbers, and we will simply return it in a new array. And you could see that all the test cases are passed, and we are performing this operation in big of 1 space complexity and linear time complexity. See you in the next question.